Hello, everyone. We're going to go over how to use R to calculate critical values and p-values. Okay, so let's suppose that alpha is 0.05, our sample size is 30, and that we have 5 variables in our model. Okay, if we run this into R, if you're in our studio, you're going to press Control Enter. If you're on a PC, if you're on a Mac, then you're going to press Apple Enter. If you are not using RStudio and you're just using R on a PC, you'd use Control R. All right, we're going to use the function qnorm. Qnorm is used for the Z distribution or the normal distribution. And when you designate lower tail equals false, you're saying, give me the Z value for the upper end of the distribution where I put alpha equals 0.05 in the upper tail. So one good thing to do to accompany this video is that if you're used to using Z tables, to be able to cross-check with those Z tables. All right, so if I run this in, essentially I get a value of 1.645. So what is that saying? That's saying that the Z value where we're at the 95th percentile. So that means that 95% is to the left and 5% is to the right, is 1.645. If we would have said lower tail equals true, excuse me, that should have given us a negative Z value, negative 1.645. And that means that that is the value of Z when 5% is to the left and 95% is to the right. Similarly, we could get the value in the T distribution. So instead of using qnorm is for the Z distribution or the normal distribution, we're going to use qt, which is for the T distribution. So if I have the same exact alpha level, right, and the degrees of freedom is now n minus k plus 1, I can get the T value that corresponds to n minus k plus 1 degrees of freedom. And I get 1.710882. Remember, for the Z distribution, that value was 1.645. Now our value isn't quite 1.645, but if I change this in here, if I changed it to 100 instead of 30, this number should get closer to the Z distribution, right? 1.66. And if I change that to 1,000, it should get even closer to the normal distribution, right? Because as we increase n, the T approaches the Z distribution, 1.646, getting pretty close. All right. Similarly, if I was doing a two-sided test, I might have an alpha over 2 here. So I just took my alpha and I divided by 2. And if we look at the Z distribution, we could do qnorm. So I get 1.96 and negative 1.96. So this should be somewhat of a familiar value to you for your critical values, because this is really saying for a 95% confidence interval, I'm going to really have the values that I'm going to plug into my confidence interval being the value at 0.025 and 0.975, because I'm dividing that alpha area of 0.05 into the two tails. 95% is in the middle. That makes it that I'm at the 0.025 percentile and the 97.5th percentile. But if I have a T distribution, once again, I need to incorporate those degrees of freedom. So here, remember our n is 30. We can get the critical value for the alpha over 2 to get our T crit. That's going to be 2.06. And if this n changed to something like 1,000 or even 100, that value should get closer and closer to that 1.96 value that we saw in the normal distribution. There we go, 1.962353, pretty darn close. All right. If we want to calculate the p-values in R, this is slightly different than calculating the critical values, because remember, if we want a critical value, we're going to give it an area and we're going to ask for the critical value. But when we calculate p-values, we're going to give it the test statistic and then we're going to ask for the area associated with the test statistic. So if we were doing a one-sided test and our test statistic was 1.53, okay, then we can use p-norm because we're saying, give me the probability in the normal distribution associated with 1.53. So here we go. Our p-value would be 0.063. So that would be larger than an alpha of 0.05. If we wanted a two-sided, if we were carrying out a two-sided test and we wanted the p-value, remember we're going to have to do 2 times the p-norm of the absolute value of the test statistic. And when we do that, we get 0.12. All right. So if we wanted to, we could do the same thing with the t-test, right? But remember, the t-test also depends on the degrees of freedom. So if our test statistic was 1.53, but we were carrying out a t-test, then we would need to use PT instead of p-norm. PT says, give me the probability on the t distribution rather than p-norm, which says, give me the probability for a normal distribution. We can take the absolute value of our test statistic, tell it the degrees of freedom, and say lower tail equals false. That's really just saying, give me the upper tail. And you can double check this with your tables. But when I do this, I get a p-value that's very close to the z-value, but it's slightly different because now we're dealing with degrees of freedom and we're not on the normal distribution, 0.0695. And if we wanted a two-sided test, we would multiply that area that we found times 2. And our p-value of the two-sided test would be 0.1391. So hopefully you might be familiar with how to use tables to calculate p-values or critical values, but this is trying to get you acquainted with how to use R. I hope you learned something today, and I'll see you next time.